will be created when we create our data set or data frame, right? What is narrow transformation? What is wide transformation? Why wide transformation? Like group by creates a shuffle, and which in turn creates a new stage. Like, and you should also understand that how many tasks will run in parallel. So number of tasks first of all equal to number of partitions we have, right? And if number of cores equal to number of parallel tasks that can run, right? Number of tasks that can run in parallel. I should write like that, right? Yeah. So these things should be very clear to you, right? And yesterday we understood how in group by we do basically Spark as a local aggregation first, so that it has to write less shuffle data, right? Because shuffle is costly, so the lesser it is, better it is for performance. So Spark does for us, but we should know how it works, right? Okay, great. So these things should be clear. Now let's continue that discussion, right? Now what we will do, we understood yesterday that why for group by I need a shuffle, right? We understood why for group by I need a shuffle because same key should be in the same partition, right? So let's say Goa was there in different partition, and if I do group by individually, it will give me wrong result, right? So first local aggregation I will do, and during shuffle all Goa will come together, all UP will come together, and likewise, right? So you understand that. Now let's understand why. Let me create a new one. Let's understand why join requires shuffle, right? Very from the first principle we are understanding, right? We are not assuming anything, anyone knows anything. Very basic level we are understanding things, right? So let's see, join requires shuffle or not, right? We will understand it. So again, let's say I have some data, order ID. Let me call it ID, or let me maybe increase some width. Yeah, okay. So let's say I have order ID, right? Product ID and sales, simple 3 columns, right? And one P100, simple. Let me make maybe some tab I will put. Yeah. Then I have two P2 200, right? Okay. So this is my order ID, right? Now again P1 can come in order ID 3 again, right? It's quite possible. So let's take that. So this is P1 again, order ID 3. Okay. So this is my orders data, and let's create at least 2 partitions to understand, right? At least 2 partitions we need it so that we understand the distributed computing, right? Because we are working on multiple nodes. So with 2 partitions we can mimic that thing. So let's say it is 4, 5, 6. So this is my orders data set, which has order ID, product ID, sales, and we have 2 products, simple P1 and P2. Okay. Now I want to join this with a product table. Let's say I want to get a product name or whatever is the requirement. So I have another table. Let's call it product table. So this is my product table now, and it will have product data. So it will have product ID and let's say name, or maybe we can say cost, price at which we purchase this product, right? And let's create data for this. So we will say P1 100, right? P2 100. Now this will also have partition. Let's say one more product is there. At least we will take 3 products. Okay. So this is also there. Great. So it has 2 partition, right? In one we have P1, P2. This will be last partition. For now we are just understanding this, right? And let's say it has P3. Okay. So this is my condition. This is my orders data, right? So it will be in multiple partitions. And whenever I read it, again, I'm reading this, right? This product data, and it will be in multiple partitions. Okay, great. Now let's join it. If I join it, right? Let's see will it work or not. So let me do one thing. Let me make this as well P3. Oh, it is fine. It's fine. Okay. So now I want to join this, right? How I will join? If you see, this product ID is P1, P2, right? Now when I join it, right? We have to make sure. Now you will say that okay, P1 is there, P2 is there, P1 is there. Now I will join with both partition I will join, or I should join with one partition. That will be a confusion. So what should happen ideally? We have to make sure that from both the data sets, right? From both the data sets, sorry, both the partition. So this is product and this is order, right? So what should happen? Let's say I'm joining this P1, right? Now P1 is there here, but it is not there in the second partition. P2 is there here, but not in the second partition. Similarly, if you see here, P1, P2, P3. So P1, P2 is in one partition and P3 is in one partition, right? So this will create confusion. What should happen is we should have partitions where same product key or product ID from both the data sets should go to same partition. Then only they will join, right? If the product ID is, let's say this is partition 1 and this is partition 1. Now P1 is there, but P3 is here, right? And if I want to join it, it will not go. So I have to make sure that same key, P1 from here, P1 from here, P1 from here, and P1 from here as well, should go to the same partition, right? If it goes to the same partition, then I can join it cleanly. So what will happen, right? We will have new partitions. So data shuffle is required, right? Data shuffle is required because this can be on executor 1 and this can be on executor 2. This can be on executor 2 and this can be on executor 1, right? So if we don't have, so let me write it, then it will be clear. So let's say this is my executor 2, right? And this is on executor 1 or machine 1, whatever you call it. Similarly, this is on executor 1. Now it will be more clear, I think. Yeah. Executor 2, right? Now, if I just join like this, right? So this is fine here, right? But for this, executor 2 data is this, executor data is this. So it will not find P1, P3, P1, P2, right? On executor 2, we don't have P1, P2 from product table. So it will not join, right? We have 2 partitions. One is on executor 1, one is on executor 2. Similarly, for product table, executor 1, executor 2. If I just join partitions on the same executor, it will give me wrong result. In this case, it is fine. It will find P1, P2 both. But in this case, it will not find P1, P2. Only P3 is there on executor 2, right? So this is not going to work that way. So it means some shuffling is required so that same key should go to the same partition, right? So let's say again we have this executor 1. So data shuffle will happen, and what will happen is same key will go on the same partition. So from the orders table, let's say P1 is there. So this is called, sorry. So P1 from product, let me write it down, P1 100, right? As well as parallelly, we will have this P1 from here as well. Right? So this is orders table and this is products table, right? So on the same partition, we have all the data of P1 from my data set. So we will have 1 P1 100, 3 P1 200. Right. Let me remove this for now. I'll bring it later. So 1p1 200 and 3p1 200 and again p1 is there, 4p1 100. 4p1 100. Right? So now what is happening on this same partition? We will have all the p1s coming together, right? And similarly, the p1 from product will also come on the same partition, right? So we will have data from product. Let's say it can be here, and it will have p1 and 100. So this means it needs shuffling, right? We cannot just join data which is present on the same executors. It will give me long result, right? Although we think that this is a row by row operation, right? In row by we have to aggregate it, but here also same key should be present on the same partition. Otherwise, it will give me wrong result. Right? So let's see. We will write code and see if this is happening or not. So let's go there and let me copy this. I think the session is running. I'll just stop it. Okay, this is done. SparkL4 code. Okay, so let's create the session. Okay, and let's take that code to read the data as well. So this is my data. Okay, so this is done. So we have DF orders, and now I will read one product table. So I'll go there, and I should have a product table. So we have products.csv, right? So let me show you quickly what we have in this. So we have product ID, product name, cost price. So we have 3 columns, right? So let's read this. So let me copy this, or maybe new cell I will do quickly. So I'll say products schema equal to, we have product ID, int, then we have a product name, string, and then we have cost price. I think it's integer. It's integer in our case, yeah. And that's it. Sorry, that's it. And then I will say df underscore products equal to spark dot read dot format is CSV. Header is there in our file. So we will say header is true. Dot schema is this product schema. Dot load. And this is my path data and products.csv. Great. Let's see if we are able to read it or there is some syntax error. Okay. So we are able to read it. Let's quickly check this as well. So df orders.show. Great. So both the tables are product ID common and we can join on the product ID. So let's do it. Right. So I will say, we discussed the syntax and all, but I'm just joining it. So I'll say df join equal to df underscore orders dot join. And we have to give the other table, df products. Right. So I'm saying join df orders with df product. Next thing we have to give is on which column. So I want to join on product ID column. Next is what kind of join? Inner join. Right. And let's see if we are getting the data. Join dot show. So we are getting the join is working basically. Right. Now what we will do? We will just do a full write to see the Spark UI. Right. Because show will not bring all the partition into picture. So we will say write dot format. Format should be no op. Right. Dot mode override. And dot save, right? Okay, so let's do this. Let's do this. So if you see, this is active jobs. So when it is running, it will come in active jobs. Once it is completed, it will come in the completed jobs, right? So it is currently running. We can go inside this. Now you can see, right? This is the stage 1, right? Where we are reading one file. Right? This is another stage for second file, right? And then exchange is happening, which means for this data as well, exchange is happening. For this data as well, exchange is happening, right? One more thing I think I missed it. I said yesterday, number of stages will be number of shuffle operations plus 1, right? Number of byte transformations plus 1. But in plus 1 means one file when I'm reading. If I'm reading 2 files, so there will be 2 separate stages for that. One for reading orders file, one for reading this file, products file, and then both are exchange, which means this is also shuffling, right? This is also shuffling, right? And then it is getting joined. So we will see. Okay. So one is product file, which is very small file, right? So it created only one partition, right? Typically we are saying that it should create at least 4 partitions if we have 4 cores or 6 cores or whatever, right? But if it is very small, then it may create only one. So if you see, this is a very small file. So I'll just show you. So it is only 4 KB, right? So if it is too small, then it will create only one partition, right? So that's fine if it is too small. Okay, so this is fine. So this is just reading that file, nothing much, right? And if I go back, this is the second stage where we are reading the orders file, where we have 9 partitions and 9 tasks, right? Right, and then it is writing the data. So this is shuffle write. So this is my input records, and this is the shuffle. So it is doing a shuffle now, and it is writing all this data on the disk. Right? And then while shuffle is happening, we have 200 partitions, right? This we discussed yesterday. That after shuffle, it will create 200 partitions, right? And some shuffles will be empty, right? Because I think we have 100 products only, so we will have maximum 100, I think. Yeah, maximum 100 partitions can have data, and it can be less also because one partition can have multiple product IDs, right? So if I just show you quickly how many product IDs we have distinct, so or we can just see number of records in product table that will give me, right? So df products dot count. We don't have duplicate in df products, so we have 100 products basically, right? So maximum 100 partitions will be busy or occupied, right? Out of 200 partitions, maximum 100 partitions can have data, right? And we can have maximum because one partition can contain product ID P1 and P2 both likewise, right? Yesterday we discussed all of this. So if you see this shuffle is happening basically, this is what I wanted to show you. In case of join, in case of group by, only one data set is getting shuffled, right? But in case of join, both the data sets are getting shuffled. So join is generally the most costly operation. It is costlier than group by because 2 data sets we have to shuffle, right? We have to write it to the disk, and then as per the key, we have to make sure same key is going to the same partition, right? From both the data sets. Okay, so this is why shuffle is required in this. Okay. Now there is one more interesting concept in join, right? So this we understand, right? This is my executor 1, this is executor 2, and if I just join within the executor, it will give me wrong result. So that's why I need a shuffle, so that on the same executor within same partition, same keys are going. Now what if I told you there is another way of doing this? Let's say I will create only one partition of this file, right? I will combine all the data of this file and send it to all the executors, right? So let's say my product table has 3 records. So what I will do, I will have combined full data of this product and I will send it to the both executor. So just imagine I have this data, product ID cost, right? And we have P1 100, P2 100, and P3 100, let's say. Or maybe it can be different. Let's put something else, 200, 300, 200, 300. So what I can do, I will say that I will not shuffle data. Let that orders data be as it is. Don't shuffle it. But this full data, I will send it to both the executor. So I will send it to executor 1 as well as I will send it to the executor 2. Now if you see, joins will happen fine. P1 will join with P1, P2 will join with P2, P1 will join with P1. Here again, P1 will join with P1, P2 will join with P2, P3 will join with P3. And we will get the right result. Isn't it? Think about it, right? And in this case, shuffle is not required. The only extra operation is I need to send this product data to both the executors. Right? If I don't do this, then in that case, I have to shuffle both the tables. So that same key is going to the same partition. But if I do this mechanism, then there is no shuffle. The only extra operation is this product data should go to both the executors. Full data, not partial data. Again, partial data will go, then it is wrong. Right? So this is known as broadcast join. Right? This is known as broadcast join because we are broadcasting the table to all the executors. Right? And this we should do only when one of the table is small and another is big. Right? If a table is small, then only we should do it because we are sending this full table to both the executors. Right? If it doesn't fit into the memory, right? When partition is there, then we are dividing the data in multiple partitions. But here we are sending the full table to each executor. Right? So if it is too big, this table, then it may go out of memory. Right? So this is known as broadcast join, and we will just see. There is another point of performance with respect to broadcast join is. So I'll go back to the Spark structure, Spark architecture. Okay. So now what happens? So we are broadcasting it, right? So basically this file, we are broadcasting it, right? Now how I will broadcast it? Because some data is there on executor, this executor, and some data is there on this executor. For product file, for product table, by default it will be partitioned, right? Some will go here, some will go here. Okay, great. But then if I have to broadcast it, what I have to do, these executors will send this data to driver, and driver will combine and send full data back to executor. So let's say product ID P1, P2 coming from executor here, right? P3, P4 coming from here. So all the data will come to the driver, and then driver will broadcast to all the executor. This is how internally it happens. Which means if your file is too big, which doesn't fit in driver memory, then also it will go out of memory here. Right? So there are two things. One is if the file is big, my driver may go out of memory because these files are first coming to driver from both the executors, and then it will be broadcasted. And second, when I'm broadcasting again in executor memory, it should fit. Right? So we should be careful about broadcast join. Generally, it is done when one of the table is small. Right? So let's see how that will happen. Okay. Now, if you remember, I was telling you that I have changed some default properties. So I will go to Spark configuration, and I'll say edit. If you see this broadcast join threshold, I have given -1. Right? By default, it is 10 MB. Which means if your file, let's say this is 10 MB, right? It means this, that if your file is less than 10 MB, Spark will automatically broadcast it during the join. If I do -1, it will never broadcast it, right? So whatever size you give, so let's say you give 100 MB, right? So if your file is less than 100 MB, it will do a broadcast join, it will send that small table to all the executor, right? So let's change it to the 10 MB, which is the default value, right? So in bytes we have to put actually, so let me calculate bytes. Broadcast join default threshold. This is the one, 10 MB. So let me copy this, and I'm going to put it here. Bytes. This is how we have to put it. And I will just save it and close it. Right? And I will just make sure I bring this down so that it reads again. Docker compose down, Docker compose up. Okay. And let's do it again. Right? So earlier we saw there was a shuffle. Right? Now we will see shuffle is there or not. So this is done. This is done. This is also done. Spark is not defined up there. Okay, fine. Okay. Let me comment this. Okay. Now we will do join and we are writing it. Perfect. Okay. Let's see what is happening. So I will go to jobs, and so if you go there, you see there is no shuffle, right? There is no shuffle at all, right? If I go there, so you see it is broadcast exchange. So it is doing a broadcast join, right? If earlier we didn't see it, broadcast means it is sending this file to all the executors, right? Earlier we didn't see it was sort merge join. We'll talk about sort merge join later, which is by default if you don't do broadcast join. But basically we see that there is a broadcast join, right? Now why it is creating 2 stages? Let's see, 2 jobs it created, right? It should have created only 1 job. Let me see. Let me run it again. Maybe I have run multiple things. So let's see. Okay, and if I come here, it is creating 2 jobs. Why it is creating 2 jobs? Okay. We are passing the schema, right? Product schema. We are passing this as well. Okay, we'll see why it is creating. But basically you can see here that there is no broadcast join here. Oh, sorry, there is no shuffle here, right? It is creating 9 partitions. For each, actually it is creating 2 different jobs. One for reading the product file and one for reading the other file, orders file. But it should have ideally be only 1 job. We'll figure it out, right? But we understand that why we needed shuffle or join, right? And how with broadcast join, we don't need shuffle. You should be able to understand this by now. Right? I'll just show it again. That in case of broadcast join, we are sending this full data of product table to both the executors, right? So because full data is available, all the products are available to each executor. They don't have to shuffle data of orders table, right? All the products are available. It will just do join. For this also, all the products are available, so it will just do join. As simple as that, right? In earlier case, some records were there in executor 1, some records were there in executor 2, and because of that, we had to do the shuffle so that same keys of both the tables present in the same executor or in same partition. Right? So this is how this join works. Okay, there are more join strategies that we will discuss later. I have a separate section on that. Right? But for now, you should be able to understand why shuffle is required and why shuffle is not required in broadcast join. Great. Now let's cover one more topic, and then we will move on to some transformations. Right? How do we do transformations with data frame API? Because there are a lot of other topics theory based, like I'm explaining this architecture thing. So I just feel if I explain you those things now, only it will be too much. Right? So let's take some time, little bit light, where we will learn transformations, right? How to do transformations, and then we will in between pick a few more topics. Okay. Now there is one more concept, right? There is one more concept of repartition and coalesce. Okay. So what is repartition and what is coalesce? So let's do this. So let's take this data, not this one, this one. Okay. So now I have this data which has 9 partitions, right? It has 9 partitions. We can see dot rdd dot get num partitions. So we have 9 partitions that we understand. Now let's say, right, for some reason I want to increase or decrease my number of partitions, right? I want to decrease. We will see why we will have to decrease or increase the partition. But let's say this is for some reason I need this, right? So what I'll do? So I'll say df orders dot repartition, and I will say that how many partitions I need. So let's say I'm saying I need only 4 partitions, right? And let's call it df underscore orders 1. Right? I'm saying df underscore orders 1 equal to df orders dot repartition 4. Now let's see how many partitions are there in df orders 1. So you see, now we have only 4 partitions. Right? So what we have done essentially is we are saying that earlier there were 9 partitions, right? Now make them 4. So what it will do, it will shuffle the data again, right? It will try to redistribute data across all the partitions. So there are 4 partitions. So across 4 partitions, it will write this data to disk, right? There is a shuffle involved in this. So earlier there were 9 partitions. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what we want, that we want it should go into 4 partitions only, right? 1, 2, 3, 4. Right? So in this case, there will be a shuffle required because it needs to redistribute the data. Right? So let's say full data is 1 GB. This. Right? So what it will do, it will do a shuffle and it will send, let's say 250 MB data to partition 1, 250 to partition 2, 250 to partition 3, and 250 to partition 4. Right? That way, it will be distributed equally. Right? So let's see in the UI also if it is happening or not. Right? So what we will do, let me remove this, and let's take this. Okay. So I'm saying df orders 1.write.format no.mode. So I have first created the df orders, right, which has 9 partitions by default. So I'm saying df orders 1 will be repartition this and make only 4, right? And I'm writing this df orders 1. Let's see what is going to happen in UI. Let's see how many jobs are there already. So we have until 3, right? And let's run this. Okay, let's refresh it. So if you see here, you see there is an exchange, right? And after exchange, we have how many? 4 partitions, right? Earlier there were 9 partitions, and now I'm saying that make 4 partitions. I'm specifically telling that I need 4 partition instructions, not 200, not 10, not 50. I'm telling 4, so it will get only 4 partitions, and this will require a shuffle. Wherever you see exchange, there is a shuffle. Right? So there is a shuffle right of 834 MB, and then it is reading 834 MB back. Right? Here we have 9 tasks, right? And then there we will have 4 tasks. Right? So this is each task is reading this much shuffle data: 208 MB, 208 MB, 208 MB. Okay, so this you understand that we can change the number of partition of our data frame. Okay, in this case I reduced it. Can I increase it? Let's see. So I'll say, let's say create 12. So earlier there were 9. So we want to see that can we only decrease or can we increase also, right? So I'm doing 12. So earlier there were 9, right? Now I'm making it 12. Okay, let's go to jobs. And this is the job. No, this is running. Okay. Again, there is an exchange, 2 stages, right? Earlier there were 9 partition and then we have 12. Right? So you can clearly see that there is a shuffle read and write. So whenever you use repartition, right, it will shuffle the data. So this is the 69 along the 70 MB. Each task is reading. Okay, great. Now, why we need this? Why would on earth someone want to repartition the data? Think about it. Why you will want to repartition the data? Okay, let me give you a couple of examples why you want to repartition the data. Let's say you are doing this join. Right? You are doing this join, and let me put it in a folder. So I will say format CSV, and I'll give the path. This is data, and this is data, and then let's say in the orders data set, I want to write it, right? Sorry, CSV. Okay. So let me run this again, right? So I'll just run this, and then run this as well. What happened? Why it is taking so much time? Is it done? Let's see what is happening here. Okay, I think it is done. Yeah, it's done. Okay, so it's done, and it is writing 9 files. Why it is writing 9 files? Because we had 9 partitions, and it is a broadcast has joined, so there was no shuffle and there were no 200 partitions, right? So there are 9 files. Now, while writing file, right, I feel these are small files, right? Why to create multiple files? I want to create maybe 2 files only or 3 files only, because overall size you see 386. Sorry, so let's see what is the size of one file. So it is around 200 MB, right? Let's say you want to create a small file. I mean, you want to create less number of files, right? You don't want to create 9 files when you are writing. So what you can do, you can say dear join dot repartition dot and repartition by, let's say I want only 4 files, right? In the output, or maybe I want only 1 file for some requirement, right? So I can say dear join dot repartition 1 dot write and all of that. Let's run this. Okay, this is done, and let's see. So if you see, there is only 1 file now, right? So there may be sometimes what happens, it creates 200 after it creates 200 partitions, right? So you might have 200 files, small 10 MB, 20 MB files, especially after aggregation, right? So you don't want to create 200 files because reading the cost of reading 200 files is also more. We will see later when we read multiple files what is the impact, right? But you don't want to create 200 300 files every time, right? So maybe you can repartition it and say, okay, I need only 1 part or 2 part or 3 part, and that many it will create, right? Now there is one more way of doing it, right, which is known as coalesce. So let's understand how coalesce works. By the way, before that, right, I want to show you that when I say 4, right? So let me call it 4 here, right? And let's make it no op. Okay, let's run this. I just want to show you that when repartitioning is happening, right, it will distribute almost equally. Right? It will distribute data almost equally. So let's go there and this one. So this exchange is happening. 4 partitions from 9, we are changing it to 4, right? And each partition you see equal. So it will distribute equally. See, almost 300, 300, 300 MB. So when I use repartition, the data is distributing almost equally. That you have to remember. Okay. Now let's see. There is another concept which is known as coalesce. So let's do coalesce this time. So let me take this. Okay, and coalesce. Right. Now I'm saying coalesce 4 and all of that, the same thing I'm doing, right? And let's run it. We'll see what will happen. Will we have same distribution or different distribution? And then we will discuss what is the difference between repartition and coalesce. Okay. This is done. Okay. So if you see there is a coalesce and there is no shuffle also. Right. Now what it is doing basically. So it is also creating 4 partitions and there is no shuffle involved. So what is happening, we will understand. If you see one partition is big, 309, and others are 256, 256, 256, right? So data is not like equally distributed, and we will know why that. Okay. So now what is happening, right? Let me explain it here. Let me create new one, and so this is your partition 1, let's say initially partition 1, and it is, let's say, 128 MB. Okay, and then similarly we have partition 2, which is also 128 MB, and let's say partition 3, this is also 128 MB, right? And we have partition 4, and let's say this is my last partition, and let's say this is, so this will be 372, right? 128, 128, 128. 128, 384 it will be, right? And let's say this is 116 MB. So basically I have 500 MB file, right? In 500 MB file, 3 partitions are 128, 128, 128 MB, and one is 116 MB, right? So this will be 384, and then this will be 116. Now I'm saying that do repartition, right? I'm going to do repartition to, let's say, 2 partition. Right? What it will do, it will shuffle it completely, and it will make sure the 2 new partitions have same data. So this will have 300 MB, so total is 600 MB, right? So partition 1 will have 300 MB, and partition 2 also will have 300 MB. Right? This is how this is working, repartition. So it is taking all the data, writing to disk, and reshuffling to make sure data is distributed equally. But in coalesce, it doesn't shuffle the data. What it does, it just combines the partitions, existing partitions. So maybe when you are saying repartition 2, it will combine these 2 partitions and combine these 2 partitions. It will not reshuffle data. It will just merge the existing partitions. And because of that, you might have partitions of different size. So if you see, this will be of 256 MB, right? And this will be lesser. And this will be 244 MB, right? And this is what is happening when I did coalesce here, right? So if I just go back, I will show you exactly, right? So this is what we did. So there were 9 partitions earlier, right? So what it does, like I'll show you. So earlier we had like this, right? Or maybe I will put it there. Okay. So we had 128, 128, 128, 128, 1, 2, 3, 4, 5, 6, 7, 8. And one more partition was there, I think 56 MB or something. We had total 9 partitions from 1 GB file, right? So when I said 4, what it would have done, if you see here, there are 4 partitions, right? 256, 256, 256, and one is 309. So what it would have done, it would have combined these 2 in 1, these 2 in 1, these 2 in 1, and these 3 in 1, right? So it is not doing reshuffling. It is just combining the existing partitions, and that is why it will be fast, right? It is combining the existing partition. It is not reshuffling the data. So it means that it will be faster than repartition. But the only thing is you cannot increase the partition with coalesce, right? Because coalesce is combining the partition. So how you can increase? Even if you give some big number, right? It will not do anything, right? So if I, let's say I give 20 or 12, Right? Let's see what will happen. Right? It will not give error, I think. Right? But it will keep the partition that many only. If 9 was there, it will keep 9. That's it. You cannot increase number of partitions using coalesce. So 9 is there and still 9 is there, if you see. Right? But if you give 8, it will make 8. So with coalesce, you can reduce number of partitions, right? But with repartition, you can either reduce or increase. Anything you can do because it is reshuffling it, right? So if you say that reduce, then it will put all the data in the 2 partition. If you say increase, then maybe it will redistribute into 12 or 15, whatever you give. But coalesce will merge the existing partitions, right? And it will be faster, right? So let's read the definitions once. So we'll go here. Okay, so repartition is used to increase or decrease partitions with a full shuffle. Redistributes data evenly across partitions, right? We saw it. Uses hash partitioning when a column is provided. We can pass a column also, we will see in the repartition. Expensive operation due to shuffle, right? Because it is a shuffle, it is very expensive, right? When you want to use it, you want better parallelism, right? Before joins or aggregation, you need even data distribution. Let's say after filter very less data in each partition, that time you want to reduce the partitions, right? Let's say I have 9 partitions, okay? So I'm telling you another use case when you want to do it. Let's say I have 200 partitions. I have a big file and it has 100 partitions, for example. And now you apply a filter. You say df.filter, and let's say you are putting a filter for state, right? Or maybe a product, right? Let's say product, or maybe product is fine, right? Product equal to, let's say, P1. Right? Now maybe after this filter is applied, all these partitions, so initially we are assuming it will have 128 MB of data. It is a big file, 128 into 100 MB, this big file, right? So 128 MB of data in each partition. After applying filter, let's say only 20 MB data is remaining in each partition, right? In that case, you don't want to keep so many partitions, right? You can combine it because we can process 128 MB of data in one task, right? So why to create multiple tasks, right? There will be more CPU, more scheduling will be needed. More the number of tasks, more things Spark has to manage. And why to have 20 MB, so many small partitions, right? So what we will do, okay, after filter, very few data is there in each partition, let's combine it, right? So I'll say, okay, maybe after all this, we have only 200 MB of data, right? So I'll say, okay, create maybe, or let's say I have 1 GB of data. Right? So I will say maybe create 8 partition. I will, instead of 100 partition, I will coalesce to 8 partition or repartition it, right? So this is another use case. Okay. So let's continue reading it. So coalesce is used only to reduce partitions without a shuffle, right? Merges existing partitions faster and cheaper than repartition, right? Can cause uneven partition size. This we also understood because it is just merging the existing partitions, so we cannot guarantee that data distribution will be even. In repartition, we can guarantee it, right? But in this, we cannot. It depends on size of the partitions and then it will combine, right? Use it when reducing partitions before write, as I said, right? Sometimes before writing, instead of creating 200, 150 or 100 files, we want 4 files or 8 files, right? So we can reduce that, right? We want to avoid small files. You do not care about data distribution, right? You do not care about the data distribution should be even. In that case, also coalesce can be used, right? Shuffle happens, no shuffle, can increase partition, only decrease partition. So it can increase or decrease partitions, right? Increase, decrease, anything it can do. Right? Even distribution can be skewed and expensive, it is cheap. Okay, repartition, reshuffle data, coalesce just merges partitions. Okay, this is also a very common interview question. What is the difference between coalesce and repartition? And I hope with the Spark UI, you are able to see it that data was evenly distributed and there was a shuffle. So this should be the answer, right? There will be a shuffle and data will be evenly distributed with repartition, and we can increase, decrease both. With coalesce, we can only decrease the partition, and there is no shuffle. It is cheap, but it can cause uneven partition sizes. Right? And we have seen all of this on Spark UI as well. So it should be absolutely clear in your mind. Okay, so we'll take 10 minutes of break, and if you have any questions, please go ahead.
Hello.
Yeah.
So few questions here. Like we are initially we had 9 partitions, right? We had 9 partitions, and using the partition we decreased it to 4.
Right.
But doesn't each partition has a maximum size of 128 MB?
That is initial number of partitions. I told you. That is for initial number of partitions. Later anything can happen, right?
Okay. I mean, I thought like 128 MB was the maximum size of a partition.
Initial. When I create a data set, when I read a data set, right?
Right.
Read a data set, right? That time it will follow that philosophy, right? But once shuffle is happening, after shuffle we don't have any control, right? One partition can have 500 MB data as well, and another can have 2 MB data as well. But imagine we are doing a shuffle, and for one key there is a lot of data, right? And all of that one key has to go to one partition, right?
Right.
So that may be bigger partition, and another can be smaller.
Yeah, but it's not like one key will go only to one partition. It can be possible that one key can occupy 2 partitions. It's just that one partition needs to have all the similar keys.
No. One key will be on one partition only, right? One key will be on one partition. It can not go to 2 partitions. Same key, let's say product ID P1.
Right.
All the P1 should go to the same partition. It cannot go to 2 different partitions. Then it will be wrong. In case of join or group by, isn't it?
Okay. Right. Okay.
So this 128 MB is initially. After shuffle, we don't have any control.
Okay.
Yeah.
And like in case of repartition, when shuffling is happening, is there any logic behind the shuffling? Like in group by, all the keys need to be in one partition. Logic like that is applied to shuffling here as well?
No. So in repartition, you can pass a column as well, like this. In that case, it will make sure that same state is going to the same partition. Right? You can pass it. Yeah.
Okay. So without passing, it's just randomly. Okay.
Yes.
But then why do we need repartition? Coalesce is better than repartition if our requirement is only to reduce the number of files.
Yeah. The only caveat is it can have uneven distribution. So one partition can be big, another can be small. Right. But in most of the cases, if you want to reduce the partition, coalesce should work. And mostly we will use coalesce only.
Okay.
The only advantage of repartition is data is evenly distributed. It makes sure that data is even across the partitions, but we cannot be sure with coalesce, right?
But is there any like real world scenario where we want evenly distributed partitions?
Yeah, we may have, right? So let's say that's what I'm saying, right? Let's say I have data, right? Let's say I have 4 partitions, right?
Right.
Now there is some filter is applied, right? And let's say in this only 10 MB data is there, right? After filter,
right?
In that maybe 100 MB, right? In that maybe not much filter happened, 120 MB, right? In that maybe 10 MB, right? Now let's say I want to create 3 partitions, or I want to distribute equally to 4 partitions, right? So that otherwise what will happen if I keep it as it is and I'm doing some more operations? So these tasks will take more time. The tasks which are processing these partitions will take more time, and these will finish early, isn't it? Right. So maybe it will take, let's say, 1 second. This is taking 5-10 seconds. This is also taking 12 seconds, and this is taking 1 second. So these two will finish in 1 second and will be sitting idle. And they will do the more work now. They are running for 10 seconds, 12 seconds. Right. Instead, maybe I can redistribute equally so that they all equally start and finish maybe in 5 seconds.
Okay.
Right. So yeah.
But I'm just thinking, when do we need to like keep this thing in mind while working on Spark?
So most of the time,
do we need to do collation?
Most of the time, this repartition of coalesce is used before writing the data. Mostly that is the use case of this.
Okay.
You don't want 200 files to be created in your disk.
Right.
So we'll use it and write it.
Okay, I think the real world use case might be like we discussed. When a data shuffle happens, by default 20 partitions will be created. So and there might be a chance that most of the partitions might be empty. So we need to redistribute the data and put it into a pack of like 10 partitions so that our data is evenly distributed.
Right. That's what I said. After reshuffle, it creates 200 partitions. Right.
Yeah.
So maybe in that 100 are empty. Right. And empty partitions will also, the Spark will process. Right. It will take check. Nothing will be there. Right.
Yes.
Can automatically coalesce it or repartition it so that they go away.
Yes.
Yeah. But we can do it, but we will see that in the new, whatever version we are using of Spark, there is a thing which will do it automatically for us. It will identify if there is some empty partition, it will automatically coalesce it, right? So we'll learn that later. How does it work?
Okay. Apart from this, so we discussed this broadcast join. Okay?
Yeah.
So currently, at present, we are using like a small table, say product. So currently it is a small table, but over the period of time, it will certainly become a huge table. In that case, how are we going to manage that thing in our production pattern? Is it like in ongoing process? If currently we are doing it a broadcast, over the period of time that same table becomes large, then we need to handle it differently.
Right. So what happens, these kind of questions may come, right? That your job was running fine for 2 months or 2 years, suddenly it is taking time. So it might be possible you are doing broadcast join, right? And this table has grown over time. And broadcast join is causing the memory issue now, right? So you need to rethink, okay, now I will not do broadcast join because this table has grown up, so I need to change it. Right? One more thing I forgot to tell, right? So we are saying this 10 MB limit is there, right? So whatever you put in this file, here we have put, right, that if it is 10 MB or less, then only broadcast join will happen, right? So let's say you have 12 MB or 15 MB file, right? And you don't want to change this setting because if you change this setting, it will be for all the jobs, right? But let's say you have a 15 MB file and you feel this also I want to broadcast it. So in the join condition you can give. So you can say broadcast like this. So what will happen now? Even if it is more than 10 MB, you are forcing the broadcast basically. So even if it is 100 MB or 1 GB, Spark will always broadcast it because you are giving it here. Okay.
Okay, question is on the Spark architecture. When you show us like when join happens, the data goes to the driver. So can you
In case of broadcast join.
So if you could open the architecture once again, explain that you should do. Is it only in the case of broadcast that the data goes to both executor?
Yeah. See, by default, what will happen? Some partition of your data will be here and some will be here, right? Now what you want? You want full data of product table to each executor. Currently by default it is not. Let's say P1, P2 is sitting in executor 1 and P3 is sitting here, right? Now what you want that P1, P2, P3 all should come here, P1, P2, P3 all should come here, right? So what they will do? They will send back the data to driver, and then driver will combine the data P1, P2, P3 and send it to both executors. If broadcast join was not required, then there is no need. Right? Then we are working on the individual partitions, and if shuffle is required, we will do shuffle.
So here, if the partitions are like very huge in number, more than the exceeding the driver's memory, then what will happen?
Then it will fail. First of all, if it is a big table, then it is not a use case of broadcast join. Right? Only in case of a small table, you should broadcast it.
One table is very small, another one is big, which is so. Even in that case, the data will go to the driver for the big table and small table.
No, only small table. So table which you will broadcast. Right. So here, the right table is by default is broadcast item. Yeah. So this will broadcast only DF products. This DF products is not getting broadcasted. Right. It has an individual partition here. DF order have P1, P2 here, P3, P4 here itself. Right. Or you can simply understand here. Right. So this is my partition 1, partition 2, executor 1, executor 2. Right? They are sitting as it is, orders data. Only the product data we are sending it to both the executors. So this table is broadcasted, not the orders table. Orders table is as it is, like partitions are there.
Okay.
Got it?
Got it.
Yeah. Okay, next.
Yeah.
Sorry, I think you got disconnected. Next.
Hello, am I audible?
Yeah, no.
So what I'm asking, I also have the same question on broadcast. So currently, how we are handling it? We are handling using the configuration. Like we are giving 10 MB broadcast condition. So whichever file which is falling in that memory, it will broadcast it automatically. My understanding is correct, right? It will not restrict it. If it is more than 10 MB, then it will not broadcast it until we say that okay, forcefully broadcast it.
Right.
Now suppose in real world scenario, we have a condition that we have some 2 GB big data frame, and we are joining that big data frame with 3, 4, 5, maybe 6 reference data frames, which are smaller in size, which can be 200 MB, 300 MB, respectively 3, 4 data frames, right? Now, in this case, I think we can both all the reference data frames are varied in sizes. So I think we cannot achieve this using the configuration, right? By setting one configuration for memory. So if we are manually broadcasting all the reference data frames, then what would be how it will work and what would be the efficiency impact? It will send all those 4 reference data to driver first, then it will broadcast all those 4 reference data to all the executors, right?
So how join happens, right? So let's say there are 4 tables. First we need to understand that, right? So this join is happening, right? You will apply one more join. So this is a channel transformation.
Yeah.
So first this join will happen. It will broadcast DF products and make it. Then next table will be broadcasted, right? You don't need all the tables together to be broadcasted, isn't it?
Oh, okay. So we are changing, but Spark will take it one by one.
Right.
In different stages?
Yeah, right.
Okay. So it will take in different stages. Okay. All the 4 tables. Okay. So basically, what we're understanding now
So if you are doing broadcast join, so new stages will not be created, right?
Okay.
New stages will be created if you are doing a normal join where data shuffle is required. Here, if you are doing broadcast join, there will not be any data shuffle. And if data shuffle is not there, will not be new stages.
Okay, so in the same stage,
They will broadcast multiple times basically.
multiple times.
Yeah. They will not be shuffle. You can try multiple joins. No shuffle if you are doing broadcast join.
Okay. Okay. Got it. Okay, thanks again.
Yeah. Yeah. Next. Anyone else? Sureshna is raising hands.
If she's not audible.
Okay. Okay, let's continue. We'll take doubts at the end. Great. So we have covered a lot of things, right? And I think at this point, I don't want to discuss more these kind of topics. Let's do some transformation and practical, right? In between, we will pick few more things, and for the end also, we will keep few things, right? So let's start with the data frame API operations, right? Great. So now we will learn everything like group by, aggregation, join, window functions, those kind of things we will understand. And now you can, okay, so before I start, I just want to mention that these things, whatever we are doing now, you can practice on the Databricks as well. Other things we were not able to do in Databricks because we don't have Spark UI access on the free version I'm telling. Right? In the free version of Databricks, you don't have access to the Spark UI because they give you serverless compute. Right? They don't allow you to create compute of your configuration and there's no dedicated compute. It is serverless compute and there's no dedicated Spark UI and all for that. But I'll just show you how you can do it. So Databricks free edition, you can just go to the edition, right? And you can sign up. I will just log in quickly. You don't have to put any credit card, nothing. It is absolutely free, right? So don't worry. This is my free edition account. Yeah. Okay, so this is my homepage, and what you have to do is, so first we want to upload the data, right? Or maybe I show you. So go to Workspace, and you can create a new notebook, just like notebook we are creating here. You can create a new notebook here, right? And you can give it some good name. Let me say Spark Demo, right? And then you have two options here. You can write in Python or SQL or Scala or R, right? So you can do anything, right? And also you don't have to create a Spark session. It will already be there. So whatever Spark session we create, it will be automatically available. You don't have to create it. You can just directly use it. So if I just say Spark and run it, so it is just running and it will give me that this is a Spark session. So it is ready-made. You don't have to create it, right? And then we can do whatever you want to do, right? So now what we need to upload some data, right? Because we have been reading CSV data. Similarly, here you want to upload it and then read it and practice the transformations, right? So you go to catalog, and in catalog you have this. You can imagine this as a database, and within that we have multiple schemas, right? So you can create a new schema. So for example, I'll create a new schema here. Add data is fine. Create a catalog, and catalog name is, let's say, demo. Standard. Okay, just demo one. If you see, this demo one is created here, right? This is kind of a schema you can imagine. You created a database, and within that you have a schema. So I click here. So you created a database, and within that you can create a schema, right? And let's say I have created a schema, Namaste SQL, and this is not external location, nothing. You can just say create. Okay, so you created a database, demo one, right? And within that you have a schema, Namaste SQL, right? Now here you can create a table, right? So you can create a table, or you can create a volume. Volume means you can upload a file. So I'll say create a volume. Volume name, let's say orders, right? And this is managed volume, and I'll just say choose catalog this and this. Okay, now in this volume, I can upload to this volume. I can upload a file. So I'll say upload and desktop setup data. Let me take this small file, maybe 40 MB file. Yeah, just upload it. It will be uploaded quickly. If it is big file, it may take some time, but you can upload. As such, there is no limit that you can upload 1 GB or 2 GB. You can upload whatever. Right. So this is uploaded. This file is now uploaded. Right. You can copy the path. Right. So I copied the path, and it is also showing me the data. Right. So just copy the path, close it, and now I will go back to my workspace, Spark demo. Right, and I will start writing things. So I say spark.read.format CSV .load, and I can pass that path. So this was the path, right? And let's say df.show. I have not passed header, true, and all of that, and schema. You can pass it. I'm just showing you how you can use it, right? And I will run it. It should not take time. Maybe for the first time it is taking. It doesn't take that much time. Yeah, so it is running now. See, it is showing me the data, right? I have not provided header, true, and all. That's why it is something like that. But now you can practice here, right? You can add a new this here, right? And you can start, right? Just like we are doing in Notepad. Now you have multiple files and all, right? And it will be automatically saved. You can come here again and open it, right? So you can practice whatever we will learn now for next couple of classes. You can practice on the database as well. It is up to you. It's the same thing, nothing different. Okay, so just wanted to share how you can use database to practice. So let's start. What we want to learn now. So let's do this and do this. Okay. So we will do df underscore orders. Maybe make it df. We will work with one data set for some time. Let's call it df.show. Okay. So this is showing me data, and we understand that this customer ID and all data type I'm giving. Right. Now let's say I give a wrong data type. Right. Let's say this is state is not string. Let's say I give int. Now what will happen? There are two possibilities now. One is it will fail, right? Because it will say state is int, right? And it will just give me error. Or it might do something else. Let's see what it will do. What it is doing, it is not failing. It is just giving me null value. Right. This by default is a permissive mode of reading a file. We have different modes, right? We have three modes basically. Right. We have permissive mode, we have drop malformed record mode, and then fail fast. So by default is permissive. Permissive means load all the records and replaces malformed fields with null values, right? If the data type is not matching or there is some issue with data, it will just replace it with null. Default mode and safest option for exploratory injection, right? So even if you don't give this option, it will treat it as permissive, or you can give it also, it doesn't matter because it is a default, right? So Spark controls how it behaves when it encounters bad or malformed records using mode, right? Default mode is permissive. Let's see if I say this one, right? So maybe I'll read 40 MB file because I can make changes and show you different things, right? So let's do this. So this is null, right? So I'll change it to string, right? And I will do some changes in the file. Let's close this and close this. And this is my 30 MB file, 40 MB file, right? Open with the TextPad. Okay, so now what I will do, right? This is a date, right? This is a date and this is an integer quantity, right? Let me put some random value. Let me put Ankit here, right? Now quantity is integer and I'm giving Ankit. Let's see what will happen. So I have saved it. And if I go here and run this, it is giving me null, which is expected in the permissive mode. Now I will read it in another mode. So I'll say dot option mode, and I will give the another mode, which is drop malformed. So what it will do, it will drop those records which have some issue, right? So it will basically drop order ID 1 because there is some issue, so it will just drop full record, right? And if I do this, oh, what happened? Okay, I need to give continuation. See, order ID 1 is gone, right? So by default, it will not drop anything. If anything is wrong, not matching the data type, it will just make it null. But if you say drop malformed, which means it will just drop those records wherever there is some issue. And last one is fail fast, it will just fail. As and when it faces that, okay, there is some issue, it will just fail. See, it is failing. And you can see the error as well, somewhere. Okay, let me check, it should be on the top. Malformed records are detected in record passing this, right? Fail fast mode, mein, this has failed. So you have 3 modes basically, right? Permissive, which is by default, then malformed, which means, drop malformed, it will drop the record, and then fail fast. Okay, great. Now, what we want? We want that my requirement is, this is fine, right? This is fine. But what I want to do, I want to see that which records are wrong, right? And I want to store somewhere else. Right? This is a basic requirement, right? I don't want null, I don't want to drop them, I don't want to fail. What I want, whenever there is some record which has some issue, right? I should be able to identify it, right? Bad records, I should be able to identify. And if I want, I can write it somewhere else, right? So for that, what we can do, we have to introduce one more column in our schema, right? And there it will store it, right? So there is this property, right? It will give me the column name of corrupt record, and this column name I should use it in my schema, right? And I'll just show quickly. Let me comment it. So this column name is underscore corrupt underscore record, right? So what I have to do, I will introduce this column in my schema, right? Let me copy this. It will be string type because it will have full record which has got corrupted, right? And then I will use a default permissive mode, right? And let me do df.show now. Syntax error. What is the syntax error now? Let me remove it. Dot load. Okay. Okay. So if you see now what is happening, there is this corrupt record. Now it is not dropping because it is a permissive mode, right? But what it is doing, wherever there is an issue, it is writing that full record to this column, right? Now if you see, we are not able to see full record, right? Many times this will happen. So in show, you can say truncate equal to false, which means show me the full data. It is showing the full data now, right? So this is the data which had the issue, and what we can do now, we can filter these records, right? We can say, give me all the data where corrupt record is not null, and we will learn that later, and then we can write it somewhere else, right? And if I want to remove them, I can also remove from this data. I can say, get me all the records where this corrupt record is null. So which means those will be the valid records, right? Basically, I have a way to identify which are corrupt, which are not, right? Because I don't know which column will have issue, it will have null, where it will go null, right? I don't know. So this will be populated with the full record. So wherever it is not null, it means that record is corrupted, and you can keep it somewhere else, right? And wherever it is fine, it will be null. Right? So you can change the name of this column again. By default, this is the name, right? Underscore corrupt underscore record. So you should have column name with the same name. If you want to change it here first. So how you can change? You can say con.set, and then you can pass the column name here, right? So it will be only for this session. If you want to do it cluster level, you can just put it in the conf file. Right? But you understand how this is working. Okay, great. So this is how you will identify the bad records and store them. Great. Now this is all fine, right? Let me go back. Let me do truncate normal. Right? So we were talking about this schema, right? If you remember, I told you there is one more way to give this schema, and that is more recommended way, right? So one is this, that you just say column name, data type, column name, data type, column name, data type. Apart from that, Spark has some native data types, right? So I think I have the link. I will quickly show you. Spark data type somewhere. Let me open it. Spark data types. Yeah. So if you see there are a lot of data types here: byte type, short type, long type, float type, double type, decimal type. So it supports a lot more data types, right? Varchar type, boolean type, date type, time type, right? Other also struct field, struct. Right, there are other struct type, right? We will learn that what is struct type, right? So there are a lot of other data types as well which Spark supports, and we can use those data types to define our DDL instead of that simple statement, right? So I will have to import all the data types first. So I will say PySpark.sql.types import star, right? So it will import all kind of data types. These are the ones, right? So let me go there. So maybe I'll create a new cell. Right? I'm importing all the types. If you want particular types, you can import it. That's in integer. You want only integer type, you can import integer type. Right? But I'm importing all. Generally, we see people will import everything so that they can use anything. Right? Now instead of this way, right? I will define in a different way. So I'll say orders underscore schema using struct, right? I'm just giving this name. Now, one of the data type is struct type. Right? Struct type. So what is struct type data type? Right? So let me control F struct type. Right? So struct type represents values with the structure described by a sequence of struct fields. Right? So basically, struct type is a data type which can define the structure of your table. Right? It is a full structure of your table. This is not just a data type like int or double or string. It is a full structure you can define in this, and within this you can pass multiple struct fields. Right? So I'll show you how you can do it. You will say struct type, and within this you will pass list of multiple fields. Right? So your list is starting here, let's say, and ending here, and you will say struct field. Right? And then you will tell the field name. So what is my field name? So struct field. Right? So field name is struct. Yeah, I think this is fine. Yeah, struct field, and you will say my first field is order ID. Right? Second is what is the data type? Right? So I will say integer type. Right? And third is optional. In this you can say true or false. True means it will be nullable. False means it will not be nullable. Right? So by default it is all nullable. You can put null values. Right? So but if you want to change, you can change it. But Spark doesn't enforce it. Even if you say true or false, you can always put null values. Okay. So this is my first struct field. Similarly, I can create multiple. Right? So let me copy this. Right? Let me copy it multiple times. It's order ID. Then next is customer ID. I think integer type is wrong. Integer. Okay. This is also integer type, customer ID. Then next we have product ID, which is also integer type. Right. Then we have price, which is float type. Right. Then we have order date, which is date type. Right. And we have few more. Let me add quickly. I'm writing in front of you so that you can absorb it, right? If I just copy paste, you will not be able to absorb it quickly. You will get confused. So I'm writing so that you absorb it during the session itself. Order status, string type, and then we have state also string type, and we have one more integer type, right? Last one, and this is quantity, right? So let's verify 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? This is fine. We are not adding this for now, right? Now, let's take this again. And I will say my schema is this one, right? Order schema struct, right? And I'll just show this. Let's remove all of that, not required. And maybe I will just fix that as well quickly. We'll make it one. Okay, right? So we are able to read it. And let's say print schema. Right? So it is integer, float, date, string, right? So this is generally you will see how people define the table structure, not like this, right? Because it has more complex data types, it's supposed to be see later, but this is a standard way, right? But there's no issue as such, big issue, even if you use this way, it is fine actually. But this you see more option. There's no performance thing here, nothing like that. Okay, but this looks like more table DDL where we define column name, then data type, and then we say nullable true or false, kind of, right? So if I say let's say false, right? So here you are saying true. So if I say false, it means it will be it should be false, right? Why it is giving me true? Nullable true. Okay, make it false. I have to give in capital false. It is not taking. Let me give it to all this. Let's see. Maybe I have to pass it to all of them. I'm not sure. Okay. This is fine. Order schema struct. It is giving me true only. It doesn't matter what I give, right? So anyway, it doesn't force it, right? Even if it is really false, it will allow you to put true value, right? So it's okay. You can leave it. Okay. So what we understand is there are two ways of giving the schema. One is simple way. We give a string, and another way is using the data types. Struct type will be the full structure of your table, and within each struct type, you can define the different fields using struct fields. These are also data type. Struct field is a field data type. This is a structure type of data type, and these are individual integer type and float type. This is how you have to think about it. Okay, great. So this also we covered, right? And we understand that. Okay, one more thing is, right, this is all fine. I mean, not related to this. Now there are some shortcut methods as well, right? So let's say I want to read this file, right? Let me take it again. So one way is this spark.read.format. You pass CSV, then you pass everything like that. Another way is you can directly say spark.read.csv, right? And you pass the CSV part directly here. This is a shortcut way of reading a particular type of file. So let me remove all of this. Similarly, if you want to read a JSON file, you can here pass JSON. We will learn later, right? Or you can say spark.read.json. Or if you want to read a parquet file, right? Again, you can pass here as format parquet. Or this is a shortcut method, spark.read.parquet, right? So any method you can use, and then you can pass other things. So for example, you are saying header is true, right? And then you are saying that my schema is this schema, order schema. No, this is schema, sorry. Struct type. Let me remove this. Right. So schema is struct type. Right. And I think this is the only thing we have to pass, right? We have the header, we have the schema. Right. And this will also work. Let me first see this. Integer float, all fine, and do show. Right. So some places you will see people have used this, some places people have used that. So just telling you in case you see any one of them, don't get confused. They are same thing. Just this is a shortcut method for CSV. And similarly, we have other kinds of files, JSON and all of that, right? So anything is fine. Again, there's no performance thing. Anything is there, right? It depends on individual developer or a project, what they are following. Both are fine. Okay, great. So this we covered actually, schema thing, everything, right? Read modes also we covered, right? We have 3 read modes basically. Great. Now we will learn how to create a different way of creating a data frame, right? So one is we learned that we said spark.read and it will just do it, right? So that's what we are doing so far, right? Spark.read, and this is method which will create a data frame, right? So this is one of the way of creating data frame, right? Another way can be that you can create a temporary table. So let me create a temporary table. So I'll say df dot create create. So there are multiple options. If you see create or replace temp view, create or replace global temp view, create global temp view, create temp view, right? Now create or replace means if a temp view is already there, right, it will replace it, right? If you just say create temp view and it is already there, then it will give you error that it is already there, we cannot create it, right? So that is the difference between create or replace and create. Now there is a global thing as well, right? Create global temp view, create or replace global. Global means let's say you have this session and you have created one more session in another temp. So if it is global, then that will be available in both the sessions, right? So if we create normal one, this will be specific to this session. In another Spark session, it will not be available, right? And its life is during the session only. Once the session is closed, its life is also gone, right? So mostly we will use this create or replace temp view, right? So I'll create, let's say, orders. Right? And I told you in the previous class or first class, I think, that you can write queries. So you will say spark.sql and you will say select star from orders. Right? And then you can say show. What is the other? I did not run this, I think. Yeah. Okay. Yeah. So I didn't run this. That's why I was saying that orders table is not there. Right? So it has created, right? And this also creates a data frame basically, right? So you can say where state equal to Gujarat. Okay, if you're wrapping it up in double quotes outside, inside you should wrap it up in single quotes, right? If you give double, then it will think that this double quote is ending here, right? So if you are outside giving double, inside you should give single quotes, and you will say, let's say Punjab, right? And this is a data frame basically. It is returning a data frame. So I say df underscore Punjab, right? So this will give you a data frame basically, nothing else, right? And then you can run anything like this is a data frame, typical data frame, df Punjab dot show. Or no, I need to remove this, right? I'm doing show. Right? So this is creating a data frame, and if you do show, it will show you. So basically, it has created a data frame, right? So this is two ways we have learned so far. One is read method, another is spark.sql method, right? Where I can pass the SQL and it will return a data frame, right? So these are two methods so far. Let's see what are the other method. Another method is simply you want to generate some data like a single column 1, 2, 3 kind of that. So you can say spark.range, and let's say 10 dot show. So this will also create a data frame with starting from 0 till 9, right? And I think you can pass a range like I need from 2 to 10, right? So it will give you 2 to. It will not give you 10. The last one it will not give. So from 2 it will give you till 9. If you don't pass anything, then from 0 it will give you till 9. Right? You can give the step size as well. Let me try. Yeah, so it is a step size like 2, then 4, then 6, then 8, and 10. Last one it doesn't give. If you have learned Python, it is very similar to that. In Python, last it will not give, right? If you are working with list or anything or range function. So this is just to create some dummy data quickly if you want to create, and the column name will be ID, and you can just create it. Right? There's no much use case as such. But if you want to generate, sometimes you want to generate a let's say running number 1 to 10, and then you want to join with something else, right? You can have some use case. You can quickly create, and this will create a data frame basically, right? Again, you can say df underscore range equal to this, and I say df underscore range dot show. Right? So this is again a data frame. And so this is the third way of creating a data frame, and here also we did it, right? Range 0 and this. Another is spark.table, right? So you can directly say df table equal to spark.table, right? And you don't have to pass any query here. You just directly pass the table name. So I have an orders table, and I'm saying from this orders table, create a data frame, right? Directly, right? So this will also do. So df underscore table dot show, right? So when you are giving table, you just pass the table name, right? And when you are saying .sql, then you can just say select star from orders. That will also work as spark.table and table name, right? And if you want to pass some filter or some aggregation, then you will use spark.sql. If you want to read table as it is, you can just say spark.table and then table name, and it will create a data frame, right? So these are different ways of creating data frame, right? Now there is one more way which we want to discuss now, right? So if you remember, we had the parallelize, right? In RDD, right? In RDD, if you remember, we discussed that we can use parallelize. So if I have some list, right, I can create a RDD out of it, right? Similarly, using data frame also we can do it. We need to create the data. Let's say this is my data in this format. So you will have a list, and in this each row will be a tuple. So this will be tuple 1, row 2, right? Row 3, right? And let's say here I have employee ID and name is let's say Ankit and salary is let's say 5,000, right? Then I have let's say 2 Sumit, let's say 8,000, and we have to put a comma as well here, right? Again comma here. So this is how you have to first create, right? And let's say 3 and say Nachiket. And let's say Nachiket has a lot of salary. And yeah, so now you will say spark dot create data frame, right? So D capital, F capital, C small. Right? And then you pass this data set. Again, for practice, generally people do that, right? You want to practice some transformations and something, so you can quickly create data instead of reading file and all, right? You can modify data immediately if you want to try different corner cases, right? So it becomes easy. So you will say spark dot create data frame, right? And let me do show. Let's see what it will give me, right? So it is giving me, it has created data frame. I have not passed the columns, right? So it is just giving underscore 1, underscore 2, underscore 3. Now here again, you can pass the schema, right? Or you can just pass the column names in a list. It will automatically identify the data type automatically. You don't have to say info schema and all, right? So what I will say my columns are this. So let's say my columns is, first one is ID, second one is name, third one is salary, right? And I will pass these columns here. Or you can pass this directly. Anything is fine here, right? And if I just do show now, it will give me this, right? And maybe I will create a data frame here and I will show you df.show. Not show, I want to do print schema. Df dot print schema. What is on? Oh, show. I don't have to do show. Right? Show will show me the results, right? So that's the problem. Right? So it is considering it as long string. Long basically big, right? So this is okay. I've given this in a single quotes. That's why it is taking it as a string. So let me remove it. Now it is fine. Long string, right? Or if you want to pass the data types as well, you can just pass the how we are passing the schema. So instead of this, you can say ID is int, name is string, and salary is int. I don't know if it will fit in int or not. Let's see, right? And this is not a list. This is just the schema columns, and you can pass here and this is also working. Integer string, right? So whatever works for you. You have to just create a tuple of each row will be a tuple, right? And within the list you can get multiple tuples. Right? So this is another way of creating data set. It is very popular during the practice, right? So you can just quickly create data and practice all kind of transformations, right? So I think we covered this as well. Great. Okay, so we have 5 minutes. We have 5 minutes. I'm just thinking, should we cover a couple of more topics or not? Okay, let's cover select. Right, won't take much time. Okay, great. Now data frame is created, right? We know data frame is created. Let me maybe create this one, original one. Yeah. Okay, so we have the df now. Now, whenever we do df.show, we see all the columns, right? Let's say I want to see only few columns, right? So in SQL, how do we do it? If I do select star from table, it shows me all the columns, right? If I want particular columns, let's say I'm interested only in order ID, order date, so I will pass those column names, right? Similarly, in this, you can say df.select, and you can pass the columns which you want to see. So I'm interested in, let's say, order ID, order name, and then I will say show, right? So order ID, order date, sorry, not order name, and I have to pass in double quotes. Right, so I'm seeing only two columns, right? So you can select particular columns, and then if you want a new data frame to be created, you can say df1 equal to this, right? So whatever transformations we do, right, it does not impact anything on the data frame itself. It just creates a new data frame. It returns a new data frame, right? Because data frames are immutable, right? So whatever in future I will apply the transformations, right? All returns a new data frame. So this returns a new data frame which has two columns. Now you can assign it to another data frame. Then your df1 will have two columns only. Dot show. Right? See, but if I do df.show, it is the full data, right? Because I did not make any change in the df, right? So this thing will be common across all the transformations, whatever we do. Right? So df.select, it will return a new data frame, and you can assign it to the new variable, and then this will be your data frame which will have only two columns. Okay, great. So this is one way of selecting the column. You can also do this. You can do select star as well here as well if you want. So you can just select star. Right? So this also takes this. Okay, so we'll say df1.show. See, all the columns are coming, right? Because I'm saying select star, but you have to give in double quotes always. Okay, great. Now in select, I want to do a few more things. So for example, let me go back. Right? Now let's say I'm saying I want in select, I can select columns, right? So for example, I want to create a new column in SQL. How it will be created? So you will say, let's say I want price into quantity. Right? So in SQL it is simple. You will say price into quantity as sales, right? And it will just work. Right? Let's see it works here or not. Right? So I will say price into quantity, right? As sales, let's say. Right? We'll see if it is working or it will give me some error. It is giving me error. And what is the error? The error says a column of function parameter with name price into quantity as sales cannot be resolved. But it is saying there is no column. There is no. So what it is saying, it is checking, okay, there is a column with this name, and it does not find it. Right? It does not find any column with this name. So it is not able to understand that this is an expression, right? It is thinking it is just a string which represents a column. Right? So we have to do something, right? What we can do, we can pass expr. Right? So expr is a function which will tell that this is an expression and it is not a column name. It is an expression. So we are saying price into quantity as sales. So this becomes an expression, and now it will work. It is saying expr not defined, so we have to import the function. So there are two things which you have to generally import all the time, right? When you are writing Spark code, one is this from PySpark.sql.type import star, and similarly for all the functions, right? You will say from PySpark.sql.functions import star. So it will import all the functions for you, and then you can use it, or you can just say expr. Sometimes you will see because you are using only expr, you can just say expr, and let's say you want another function, let's say sum. So you can import only those which are required. Generally, you will see people say star, right? And now it is working. You see, let me take other columns as well so that we can verify price, quantity, right? And yeah, you see 137 into 1, 137, 134 into 3, 403, right? So you can pass expr. Okay, great. Now there might be another column you are creating, right? Let's say you are creating one more column where it is like price divided by quantity. Just random I'm taking, right? Price divided by quantity as sales one, let's say, right? And let's see if it is working. It is working, no issue, right? Now, every time you are writing expression, you have to give multiple times expression, right? Instead of that, you can use select expr, right? Now you don't have to pass this expression. Maybe I will take in a new line. Let me comment this. And you will directly use expr, select expr, and you can just remove it then. Right? So it will treat it as a expression always. Right? So it is working perfectly fine. Right? So you can directly use select expr, and it will just check if it is expression, then it will convert it into expression and calculate it basically. Okay, great. So this is how you can write expressions within the select statement, right? Now, there are two ways you can select the columns. One is this. This is known as string method, right? I'm passing just a string, right? I'm passing this as a string, order ID, order date. At the runtime, what Spark will do, it will check, okay, if order ID is expression or it is a column, it will consider it as column. It will consider it as column, right? When you see expr, for everything it is checking if it is expression or column, right? So that is one way. This is known as string method. You are passing it as string. Another way is you explicitly tell that this is a column, right? You can tell that this is a column, and that is known as column method, right? So if you see, we can pass it as columns as well, right? So I'll show you quickly, and you will say select. Right, let me remove this, and you will say column, right? And you are passing it as a column. So this is a column, right? And here again, you will say that this is a column, price is a column, right? Into again column, and this is a column. So you are explicitly telling that this is a column, boss, right? This is not a string, right? And you are telling that this is a column, treat it as a column, right? Let me remove all of that. So select column order ID. So you can mix and match as well. So this is you are giving as column. This is as a string. This you are giving as a column. This you are giving as a column. And if I just run this, it will give you the price into quantity. Right? We'll see how we can alias this. But basically, we are able to directly without EXPR, we are able to do it. Right? Because here it was going it as a string. So we have to explicitly tell that this is an expression, not a string. Here we are telling this is a column itself. So this column multiplied by this column. Right? So this becomes so we don't have to pass EXPR basically. Right? So there are different ways. It is not that this is better or that is better. Right? This is basically very SQL type of syntax. Right? In SQL you do like this only, price into quantity as sales. Right? Here it is a little different. You are saying this is a column, multiply, this is a column. Right? So anything you can use, whatever you're comfortable with, but you should know both because maybe you are working in a project which has a code base already. So they might be using this terminology. So you don't want to mix and match, right? You want to continue with this, or they are using this, then you want to continue with this, right? So you don't want to make the code different, right, for every line. Okay. There are other ways also. So you can also say there are two more ways to selecting column, right? And you can mix and match. You can also say df. So this is my data frame name. So you can say df dot order date, or another method is you can say df, and within square brackets you can pass the column name, right? And you can always mix and match. So there is some other df order date. Okay, so this is also a thing. So there are four ways. One is normal, you pass it as a string. Second is you say data frame name dot column name, right? This will be useful when we are joining the data sets, right? Because by joining, we want to tell that which column is coming from which data frame. So we will have to use this method at that time. Otherwise, if it is a single data frame, then you can generally people will use this call method or string method, whatever. But there are four ways basically. Call method, df dot data frame dot column name. Then you have this is similar to pandas. These two works in pandas as well if you have learned pandas, right? And then this is a call method. Okay, I think that is it for today. There are a lot of other things we wanted to cover, but we don't have time now, right? Great. So can you tell me that whatever I'm doing here, right? I'm just creating a new column here, right? I'm creating a new column. Is it a narrow transformation or wide transformation? Quickly in the chat. Is it narrow or is it wide? Everyone is saying narrow, and it is narrow, right? We all understand why it is narrow. So when this, let's say these four rows are in one partition, right? I'm just making up, right? And from 5 to 9 is in one partition, right? It doesn't matter, right? When I'm calculating price into quantity, I can just calculate from here. I don't have to check another partition. There's no shuffling required. I can just simply, whatever data in partition 1 for all of those rows, individually I can calculate price into quantity, price into quantity, price into quantity. So there will not be any shuffle. I'm not saying showing you Spark UI, but for you it is important. Whatever transformations you are learning, right? You every time you see Spark UI, right? So it will sit in your mind. What is narrow, what is wide? Someone is asking you when you're sleeping, you will just immediately tell. Right? So you every time see Spark UI, I will not show you because it will take them a lot of time. Because for everything if I show you Spark UI. But when you are practicing, you just go run every query and see the UI. What is the job that is running? Is it shuffling or not shuffling? Right? Then it will be absolutely clear in your mind. Okay, this is how you will learn, right? By looking at me, you will not learn, right? You have to practice double. Whatever I'm doing, for everything you have to do R&D, right? You have to make sure all the concepts are clear with respect to every transformation. And we will learn a lot of transformations, right? I think another 2 sessions we need to cover a lot of transformations are there, right? A lot of them. You see, I have created the full notes, so it will take time. But for you, it is important that you understand which is narrow. If you think logically, you will tell. But still, I will say just to be sure, see the UI once, so that there is no confusion tomorrow, right? First you think that it will be narrow, right? And just make sure you go to UI and you confirm it, right? And you will feel confident then. Okay, great. That is it for today. I will add some quiz and assignments. I don't know assignments. Actually, we needed to cover some more transformation. It is simple one. I can just create some assignments. But mainly, you have to just make sure those things are clear, right? Shuffle, join, broadcast join, and initial number of partitions, repartition, coalesce, right? So I'll tell you some of the very, very common interview questions, right? Before we end the session, right? Very common interview questions is initial number of partitions, very common. Second is difference between repartition and coalesce. This is favorite of everyone, right? You should be absolutely clear. Pros and cons of both. You know now what are the pros and cons, right? Another one is when shuffle will happen. Right? When shuffle will happen and it will lead to your narrow and wide transformation basically. Right? This will lead to narrow and wide transformation. Another one is how many tasks will run in parallel. Right? Pretty simple. The number of cores. If you have 4 cores, 4 tasks will run in parallel. Right? So if you have let's say 12 partitions, which means 12 tasks, right? So first 4 will be processed once, then next 4, then next 4. Right? So there will be 3 cycles involved. So you have to answer like that clearly, right? Just give very small answers. That 4 will run. You just tell if there are 4, then 4 will run in parallel, and then next 4 will go, and then next 4 will go one by one. Right? As soon as one task is finished, one more task is assigned to that code. Right? So this is how you have to answer very elaborately. If you answer, it's like if you answer 1 or 2 questions only elaborately, the interviewer will know, okay, you know Spark. Right? In first and second answer only, he will know you know Spark. Then it will be just a matter of time. He will ask few more questions and it's done. Right? So from the first question itself, show them that you know Spark. Great. I'll open it for doubts.
Hello.
Yeah, go ahead.
Hello. Thank you. Just wanted to discuss one thing. It's related to the architecture where we have read that when we submit our code, so we have master, and master main work is to distribute the work.
Driver,
so, yeah. So this cluster manager, where does it reside? I mean, is it a separate machine? Because as it is a part of cluster only, but we are showing it is a separate thing. So where does it reside in the architecture?
Here it is. On which port it is? It is master 8080. Yeah.
You mean master node?
Yes. Here only our resource manager is for the standalone cluster.
Okay. So is it?
I can confirm for standalone cluster where this resource manager sits. In Spark standalone cluster, the resource manager is the standalone master, right? This master processes runs on this designated node and all that, right? Standalone master and worker. So it is on the master node basically, resource manager. See, 8080. Okay. So it is sitting here, and it has all the information that we have 2 workers, and this is the memory, this is the core. So it will accordingly, this is the application running, and it will accordingly assign the resources. Tell the driver, okay, you give these resources to this job and all of that stuff. Great. Next,
Hello.
Yeah, Kastu.
Yeah. So Ankit, when we define the schema in two ways, either a string or a struct type of thing, do we see any comparison performance from one side?
Nothing. Performance-wise, there is no difference.
Okay. And when we in the reading mode, when we define the columns for the corrupt records, do we have a mechanism to exclude some columns from mismatch? Maybe some column I'm expecting that it can get some mixed data types in future as well. So is there a way I exclude that column from this check?
I don't think so. We can do some research. I don't know if we can do it. Maybe we can drop the column and then do it. No, but this is doing the read only, right? Not sure. You'll have to check us, though. I'm not sure if that is possible.
Okay.
Yeah.
I have a question from yesterday's class.
Yeah, right.
So, in case of like group by wide transformation, shuffle is required, and whenever shuffle is there, new stage will be created, right?
Right.
So like in stage 1, shuffle right will happen, and in stage 2, shuffle read will happen.
Exactly. Yeah.
And you said the number of stages is equal to 1 plus number of wide transformations.
Right. But when we read two files, right, there will be two stages for each file plus number of file transformation like that.
Right. So, so in case where there is only one file, and one group by will have 2 stages.
Right. Exactly.
Shuffle right and then shuffle read.
Right.
What if there is another group by?
Then
Then
there will be one more stage.
then we'll have 3 stages.
Right. Exactly.
Then like in stage 1, shuffle right will happen. In stage 2, shuffle read will happen, and then in stage 3.
Stage 2 write will again happen, and stage 3 will read again.
Okay.
Yeah. So stage 2 will read first and write again.
Okay. Okay. Yes. Okay. For this,
Actually, you can do and see. You don't have to imagine, right? That's what the beauty of it. That's why the Spark UI I love so much. Like whatever is coming in your mind, you do it and see it in the UI. It will be then clear. Absolutely.
Okay. And like that formula 1 plus number of wide transformation. The logic behind is because of the shuffle only we are seeing the extra stage.
Right. There's no other way new stage will come. Right. Only in case of shuffle, new stage will come.
Okay. Yeah. That's all. Thank you.
Yeah. I hope you guys are enjoying the sessions, right? Because if you're not enjoying, then there's no use, right? I put so much effort to organize this course in a way that it is fun, right? And I hope you are having fun. Yeah. Next.
Hi, Ankit, Prasad this side. So I want to ask a question. Like here we are passing schema information explicitly, right? So here we are having manageable column. So what if we are having multiple columns, like 20 plus? Then each time we need to pass it manually, or there is another way?
What each time? This is like you will write this code once and then it will run in production. You're not every day writing and running it, right? Isn't it? So you have to pass the schema. If you are reading, let's say 3 data sets in your pipeline, then 3 schemas you will create and pass it. So you will have to create this, right? And it doesn't take time. You just get a list of columns and make it quickly. Nowadays you have ChatGPT, you can take help of this. Maybe you can pass in this format and tell ChatGPT, okay, convert it in this format. So it will just convert it to you immediately if you don't want to type it.
Okay. And one more doubt I have from last session. So after if you are performing wide transformation and before shuffling stage, we are storing data into the disk.
Right.
Yeah. Same thing is happening in Hadoop as well, right? After map stage. So you mentioned that it is IO extensive. So how Spark is handling differently?
Yeah. So in case of MapReduce, what happens if you are writing multiple MapReduce, right? Multiple transformations. Every time it is writing to the disk, right?
Yes.
Disk. Right. Then again, next MapReduce will pick it up, and then again it will write. Right. So there's a lot of disk IO. In Spark, everything will be chained together until unless there is a wide transformation. Only in case of wide transformation, it will write. Otherwise, everything it will chain together and run it in memory. Right. So it will reduce a lot. Apart from that, Spark is doing a lot of other optimization like local aggregation and other things also we will see in future.
Okay. Got it.
Yeah. Okay. Next.
Yeah, hi Ankit. So you were explaining about this reducing the partition using repartition algorithm. Right? So in that case, if we reduce the partition, will it affect the parallelism of Spark? Will the performance also reduce, or it will not impact anything on the performance?
So it depends, right? So for example, you have 4 cores, right?
Okay.
Now what we are saying, 4 cores, we can easily give 128 MB of data, right? It is optimal size, right? Which means, let's say if I have 512 MB of data, I can create 4 partitions. Now you already had, let's say, 100 partitions, right? And those had less data, let's say 5 MB data, right? 5 MB, right? So total 500 MB data you have, right? But to process this 500 MB data, Spark will have to run 100 tasks, isn't it?
Yes.
So it will process 4 tasks, then next time 4 tasks, then next time 4, then 4, 25 cycle it will process. And every time it will process small data. Instead of that, I will say, okay, repartition it or core as to 4, right? And then all 4 partitions will take a little bit more time because here it is 5 MB, here it is 128 MB, right? But it will be faster because in one cycle everything will be processed.
Okay.
Yeah.
Thank you.
Okay. Next. Anyone else, Nachiket?
Hey, Ankit, Karthik here.
Yeah.
That could be a silly question, but a continuation to the point that you just discussed about partitions. So let's say we have split the data into like this 100 partitions and then you have 5 MB each. And this is when every time you have to keep checking, do we have to keep checking for the number of partitions being created and the size of each partition so that we can find out how many partitions we have to do? I mean, to find out the number of repartitions to be done, like 4 or 5, whatever it is, we have to keep checking at the data present in each partition, right? Only then we will be able to find out an ideal number.
Right.
So let's say in production we have a piece of code, we've written everything in a sequence, and we've assumed that 4 partitions or 5 partitions would be enough based on the current data. But in future when it increases, we will have to keep checking the data in for each partition and then keep changing the code, right? So is there a way to handle this dynamically?
Yeah. So we have a adaptive query enable some one parameter, right? We will discuss it later. So it will adaptive query executor. So we will discuss it later, not discussing it now because it handles multiple things, right? So we will see that, and it is very useful, right? So yeah.
But this can be used to handle this scenario dynamically.
Yes.
Okay. Yeah. Thanks, Ankit. That's it. Bye.
Yeah.
that's all. No difference.
Okay, great. So guys, again, nothing much on assignment side. From next week, there will be a lot of assignments because I can give you business questions, right? Top secret of this, that, because we have not learned it. So I'm not giving, although you can do it with Spark SQL because you all know SQL. But this is not for SQL practice, right? We are not doing SQL practice here. The more important thing for you is you understand all of this and you also do by yourself, right? You create multiple files, 140 MB files, 300 MB files, 1 GB, 2 GB. I have given you a script. So create different size of files and see how many partitions are getting created, how many running in parallel. All of that you should do R&D, right? There's nothing much that I can give you assignment. You know what you have to do, right? So make sure these things are clear. Next week, mostly we'll go in the transformations, different kinds of transformations, and then following week we will understand a few more concepts of performance related and architecture related. Okay, great. Have a good week. See you on next week. Great. Welcome everyone to day 4 of Namaste Spark Bootcamp. So yesterday was, I think, one of the most wonderful sessions we had, right? And I hope you enjoyed that session and you also practiced that and you understand clearly few things, right? Let me write down what you should understand by now. You should understand that how many initial number of partitions will be created when we create our data set or data frame, right? What is narrow transformation? What is wide transformation? Why wide transformation, like group by, creates a shuffle and which in turn creates a new stage. Like, and you should also understand that how many tasks will run in parallel. So number of tasks, first of all, equal to number of partitions we have, right? And if number of cores equal to number of parallel tasks that can run, right? Number of tasks that can run